Hello and welcome to another video on Homewood Avenue lights. I'm Rabbit, and in this video I'm going to go into a little bit more detail about the different types of controllers. We use all light Arama, as I've stated before. These are how we do videos. Doesn't necessarily mean it's the best or whatever, but for us it's the best. We like how it works. We're more than happy with the power of the software and all that stuff. And the control units seem to work very well. We've never had any issues with them. Support's good with them, but that's just our choice. I am fully aware there's other brands out there, there's other types of software out there. Do your research, make your own decision on what you want to go with, and go with that. We use light Arama. We do like how well they work together, the different types of controllers, how easy they are to configure and set up, so we're happy with them. But anyway, back to the controllers. The first controller I'm going to show you is what they call just pretty much a standard 16-channel PC board. It's kind of the ones that started the whole thing with computerized lighting. As you notice, these boxes look identical because they are. It's not the box, it's what's inside the box that's different. This is your standard 16-channel PC board. The way it works, they come, if you buy them already assembled and all that stuff, which you can. If you want to save a little money, you can put the cords in yourself. From light Arama, they'll come with 2 power cords. The reason for 2 power cords is if you're running incandescent lighting, which is just your standard old lighting, you have to be mindful of your power draw. These things, with the lights, if you put enough incandescent lights, they take a lot of power. Too much for one cord to handle. So they actually come pre-wired with 2 cords. So you can actually plug it into 2 sides of an outlet so that you're not overloading a circuit or anything like that. As I stated before, incandescents, you have to be very mindful of your power draw. We use all LED, which is very minimal power draw. So I was able to take these down and just do a little jumper wire inside there to run them off 1 power cord. Inside the box, your power cord, basically when you're running the 2 cords, 1 cord's powering one side, 1 cord's powering the other side. I just simply put a little jumper cord in there so that 1 cord powers both sides of the board. The way they are, and this is why they call them 16-channel, there's 16 of these cords coming out of it. Each cord is independently controlled, so your computer will tell this to turn on and off at certain times as you have set up in your software. There's a video on the basics on your software to give you an idea how that actually works. But for this part, it's just the controllers we're talking about. So a standard 16-channel, anything that plugs into 110, regular Christmas light strings, summer rope lighting and all that stuff. Like I say, anything that has a regular 110 power plug on it, you plug into this, the computer talks to them, tells it, I want this one turned on at this point, then I want to turn this one on. You can get really inventive on how you do things. You can make chase scenes where your lights go boo-doo-doo-doo across your yard or whatever, and that's all done in the software. There'll be, like I say, there's a video on that just to give you the basic idea on that. Standard 16-channel board. That's the way it works. 110 volts. Everything you plug into it's 110 volts. Next one I want to talk about is for the dumb RGBs. That's the ones that, as we've talked about in other videos, that have to do all 1 color. Now this one's a little harder to see because it's kind of like buried in behind the wires, but down in here is a channel board. I believe light Arama calls it the CMB or CMD 24. It has 24 circuits. An RGB light, which is red, green, blue, takes 3 circuits. 1 for red, 1 for green, 1 for blue. This board is set up and marked to do 8 3-channel circuits. So you got basically 8 cords coming out of it that'll run 3 circuits on each one. So if you got an RGB flood or something plugged into one, you need 1 for red, 1 for green, 1 for blue. You just simply have to plug one into here, into your board, and it's the same deal. It talks to the computer tells it which one to turn on and off, how you want to do it. And if you're running an RGB, obviously if you want red, it turns on red all the way. If you're wanting different little colors in the rainbow, it'll vary the amount of power going to each one and give you that specific color. These do not have a power cord on them. You have to add a power supply, a 12-volt power supply. That's what you see right here. Now that will obviously plug into 110. So you plug that into power, hook your Cat 5 cable into these, and then hook into all your other lights and all that stuff and do your programming. And as I said, on the software, we'll show you how that's done on that. But that's your dumb RGB controller. 24 individual circuits, kind of broke down into 8 different ones, so it's 3 times 8. So you'll have 8 cords coming out, and you notice these are special cords because you can't use regular 110s. You have to use 12-volt RGB bulbs on them. But that's how that one's going to work. Now the last one I'm going to show you is the smart pixels, which you see running in the background. These are a little different yet. These are the pixel controllers for the smart pixels. Now I'll say this much, when you go start doing smart pixels, make sure you do a lot of research and know as much as you can ahead of time on how these work, how to set them up, and everything else. The smart pixels are definitely the newest, latest thing in Christmas lighting. You see them around the background, and it's because you can do all the special effects. But these do require a little more work behind the scenes, so to speak. Setting them up, thought process, making sure you got your props right. It's not just run a string of lights and go. They work great, but they do require a little bit more work. I'll have a whole nother video just dedicated to these pixel lights and some of the things you're going to need to know about them, and maybe help you get your system set up if you're going to use these. This one is the Arama Pixie 16. They make different ones on these. There's PixCon 16, there's a Pixie 4, there's a Pixie 8. When you're dealing with just the Pixie series, the number means how many circuits are in it. This is a Pixie 16. There's 16 circuits in it. It means there's 16 cords coming out of it. I've currently got this one set up, and it's actually hooked to my computer and it's running. You see the lights in the background. That's why I'm kind of down here doing it. They're just on stands that I use to stick them in the ground normally, but they're sitting on this side of this. As I said, it's a 16 channel or circuit board, so I got 16 cords coming out. Now the way our system is set up with the Arama software and all that stuff, and using this particular board, the Pixie 16, there's 16 circuits coming out. Each one is capable of running 100 lights. You can change some things on it using Arama and all that stuff, and changing your style of network cable and that you're running. Not so much your network cable, but just the way the whole thing talks. And you can increase that some. I think you can increase it up to 150 lights per string. We found, just for simplicity purposes and what we're doing, 100 lights per string is more than adequate. These also require their own power supply. As you've seen in the dumb pixel, it has to have its power supply. This particular one, because we are running 1600 lights out of it, that they take quite a bit of 12-volt power, there's a secondary box. This one right here has the 2 power packs in it. Because of the amount of power, and you can do a little math on it, see what your power draw is on these, but we're talking minor amounts. Each one of these powers half the board. So that way we've got more than enough power to power all these pixel lights. So when you're thinking about doing these, make sure you understand that when you're doing an RGB, white is the highest power draw, because it's all 3, the red, the green, and the blue at full power. So when you're doing your math and all that stuff, give yourself some leeway in case you're using white a lot to make sure you got enough power on it. The way I hooked them together is these here are 3-wire connectors. There's 3 wires in each cord, but you can get them in a 4. Right here, it's a 4. I just use that to hook the 2 together. 2 wires from each power supply coming over to the circuit board, up, and powering each half of the board. So we're working good. So, but like I say, if you're going to go into the pixels, make certain you try to get as much research and as good an understanding as you can how to work with them, how to set them up in the computers, They do require a little more work, and some things you have to do with them when you're building your props and all that stuff. Just make sure you do a lot of research to fully understand, to make these work and make them as easy as they can for you, and make sure they work like you want to make them work. Okay, so that's your 3 basic types of boards, the control units that we use. You can mix and match, we do, and it's literally just when we go to set up and all that stuff, the Cat 5 cable comes from the computer, it goes to the first controller, which is usually the closest controller, and then from that controller I run to a Cat 5 cable to the next controller, from that controller to the next controller, and just go all the way down through the line. So you're only running 1 cable to your computer, and then from there you go to the next box, and on down the line. The one thing you have to keep in mind though is you have to give each individual box a unit ID number. I'll show you that real quick on one of the videos with the software, and it's not a complicated number. This right here, this is box number 1. We have 5 of these that we're using right now in 2020, so it was literally box number 1, box number 2, box 3, 4, and etc. The RGBs, just do the way I was thinking ahead and all that stuff, it's box number 8. The pixels, they're a little bit different on the numbering and what they require, but it's the same thing. This pixel running right now is box number 10. So that part's real easy. But that is something you have to make sure you do whenever you buy a new one. They always come in from Arama as unit number 1. That's just their standard setting on stuff. You just real quick go use your computer and change it to whatever ID number you need it to have to make it work in your system. So hopefully that helps you understand a little bit more about the different control boxes. So until next time, make sure you hit that like and subscribe button. We'll see you next time. God bless and enjoy.